Hello everybody and welcome back to our fourth lecture of Gaming 4317 Arts for Gaming class. And so far we've seen the 3ds Max environment. We worked a little bit about and with the 6 different parts of designing a model or a scene, or essentially a production in 3ds Max. We learned a little bit about the basics of modeling, animation, materials, and rendering, and so forth. And today we continue about modeling three-dimensional objects in 3ds Max. So basically the objectives of today's work and lecture is learning about how we can use a model and duplicate this model, and then we learn about the notion of clones, basically references and instances, and also we talk about instance modifiers. We learn about the 3ds Max data flow, how an object in 3ds Max is created, and how the transformations and modifications applied on an object will be manifested and applied on objects that are made from the main object. Then we learn about how we can use two-dimensional shapes and text to model three-dimensional objects. We learn about loft compound objects and how we can use two different two-dimensional shapes to create a three-dimensional shape. We learn about polygonal mesh objects, and finally advanced transformations. We probably will not get to the last two parts, and that would be the continuous or the continuation of the third chapter of the class. And after this, we start working with more advanced modeling using NURBS and other advanced modeling techniques to create more realistic objects. But probably the first four components of these 6 objectives can be covered today, and we'll see how much of it we can work on. Okay, to start up with the first objective or the first topic that we'll study today, we'll talk about objects that you may want to create and then make copies of them in a scene, such as, for example, a row of columns in front of a building, the legs of a chair, or things that you have multiple copies of the same object in a scene, and you don't necessarily want to recreate the entire model. These objects are called clones. Basically, they are copies of models that you create. In order to make a copy of a model, let's say that you created a leg of a chair and you want to copy it, you could left click on the object and select it, and then by enabling the select and move gizmo, and then while controlling the shift button, you could drag the object and transform it or translate it, and this way you will open the cloning dialog. There will be 3 objects in the clone option dialog box that you see, and these are copy, instance, and reference. And then you can choose how many number of copies you want to create, and then you can give them names. The copy clone is a clone that has no relationship with the original object or the master object. That is, if you apply a transformation or a modifier on the object's parameters, on each of these object's parameters, the other object will not be affected. The second type of clone object that you can create are called instances. An instance object is a clone that's always in a two-way relationship with the original object. That is, if you apply a parametric change on each of the objects, the other one will change. If also you apply a modifier on an object, the other object will also change, whether you apply it on the instance or on the master object. This is useful when you want to create objects and apply modifications and you want to keep multiple copies or multiple instances of that modified object, such as the legs of a chair or a column of a row of columns in front of a building, as I mentioned earlier. In this case, you make an object and you make copies of it, and then you make changes to one of these objects. The other ones will change accordingly. So this saves a lot of time. The third kind of object is a reference object. A reference object is a specialized type of instance object, and it is basically in one-way or two-way relationship with the original object, which is also called the master object. Depending on where in stack you apply the modifier on the instance object, the original object may or may not change. And we'll see that how it actually works in a quick tutorial that I'll just show you in a few seconds. Essentially, when you're looking at the modifier list or the modifier stack, the objects or the modifiers that are applied on both the master object and its instances and references will be shown in boldface, and the ones that will be only applied on the reference object will be shown in just a regular type face. And so let's go to the 3ds Max, and I will show you how we actually can make copies, instances, and references from objects, and how we can make modifications and basically apply multiple modifications or just one-way modification on just the instance on the reference object without changing the master object. Okay, here we are in the 3ds Max. I maximized the perspective viewport just to show you the three-dimensional view of the objects that I will create. And I'll show you here how the notions of clone copies, clone instances, and clone references work, and how the modifiers will be applied on them. So first, let's start by making a box. And so you go to the object, the geometry, and from the standard primitives, I'll choose a box primitive, and then I'll make a box just like that. And then I'd make this name to be the box master. Okay, so this is by box, and I can modify its properties by left-clicking and dragging on length, width, height, and other components of this object. So let's make the height segments 10 and length and width segments 1. So this is my master object that I created, and now I want to make a copy of this object. If I move the left button and translate this object along X direction, and while holding the shift down, it will create a copy of this object, and then I can choose object copy and then call this object box copy. Notice that these objects are different. Essentially, if I make any changes to the height of this copied object, nothing happens to the original object. Same with the number of segments in the object. If I change them essentially from 10 to any other types. Also, I can change the color of this object, and nothing will happen to my original object. It could have different materials and stuff like that. And of course, when I'm translating this object or moving this object along X and Y direction, nothing will happen to the original object. And same with if I do that with the master object, it won't apply on the original object. Now, let's make an instance of the original object. I'm holding the shift button down and left click and drag along the X direction, and I make an instance, and I call this box instance. Now notice if I change the height of this instance object, the original object will also change. If I change the height of the original object, the instanced object will also change. That is the properties that are applied to the object properties itself. If I change the color of this the instance object, or essentially change the material of the instanced object, that will not apply to the original object. And same is true if I change the color of the original object, it will not be applied to the instance object. If I transform or move the original object along any axis, or even the instance object, nothing will apply to the original object either. This is the idea of branching. What happens here, you see, when I created the object and I created a copy of this object, nothing was shared. Essentially, the object had properties such as width, height, it had a size, shape, number of segments and stuff like that. These are the properties, the object parameters. And then each object had their own properties such as colors, and each object had their own transformations, that is their location, orientation, and scale in the world, and none of those were shared. So the object properties, object parameters, and object transforms were not shared. And same is true with modifiers for objects and copies. For objects and instances, as you notice here, their properties, their colors, their materials are not shared. Their location and orientations, or essentially their transforms, are not shared, but their parameters are shared. That is, if I change the height of each object, the instance or the master, the other one will change. So when you look at this pipeline of object creation in 3ds Max, you will notice that in 3ds Max, between objects and copies, nothing is shared, but between objects and instances, their object parameters are shared, but their transforms and their properties are independent. How about modifiers, and how about the modifier stack? If I apply a modifier, such as a taper modifier, on the instance, so I can click on the modifier stack and I apply a taper modifier on the instance object, as you see here, and I change the amount of taper, you'll see that the instance object's modifier applies also on the master object. But that does not apply on the copy object. That is, if I go on the copy object and then I apply a bend modifier and I bend the copy object, the master object will not change. Now let's delete the bend modifier. And then let's apply a taper modifier or a bend modifier to the master object. So let's go to modifiers and go to parametric deformers and then click on bend. Now if I apply the bend modifier on the master object and I change the bend value, you see the bend also applies on the instance object, but does not apply on the copied object. Okay, so this essentially would show us that there are several parts that are essential in creation of objects in the 3ds Max pipeline or 3D graphics pipeline. And for the objects and their clone copies, or the ones that are just copied, nothing is shared. Objects have different object parameters, they have their own modifier stack, and they have their own transforms, and they have their own properties such as materials, colors, and things of that nature. Now, having different properties for different objects makes sense, because if you want to have objects having different materials, you would have to be able to assign different materials to different objects even though you copied them. And the transforms being different also allow us to place objects on different places and areas, because transforms are essentially rotations, translations, and scales. And in this sense, they are individual to objects instances and objects copies, and they're not shared. However, for objects and object instances, you want to be able to apply the same transformation on objects and their instances, whereas you don't want to apply the same modifiers to objects and their clones. or copies. So modifier stack is shared between the objects and instances, and it's not shared between objects and their clone copies. Object parameters, such as their sizes, their radiuses, their heights, are also shared between objects and their instances. Now, in this sense, you can apply transformations on both objects and instances, and each one would affect the other one. And these transformations are modifiers, modification transformations, or parametric transformations. Now, what happens if you wanted to apply a modifier just to a copy of the object, but not to the object itself? So, for example, for instance, how about if I wanted to apply a noise modifier to the objects and their copies? Now, let's apply another modifier to the instance, and let's apply a twist modifier to the instance, and let's increase the angle of the twist to 180 degrees. And here's my twist modifier, and I have the bend modifier. Let's make the bend modifier something like this. So as you see, the bend and the twist modifier are applied on both instances and copies and objects. Now, if I hold the shift and make another copy of this master object and make it a reference object, and let's call this the reference object, you see that I can now change the parameters of this reference object, or the box here, and this also changes both the reference, the instance, and the master. And if I apply a modifier just to the reference, let's apply a noise modifier just to the reference object, and the noise modifier applied to the reference object would have to be above this solid gray line just to apply to the reference object, and the twist and bend below this solid line are applied on all the three objects: the master object, the instance object, and the reference object. So this is good because now I can apply a noise value, let's say with the value of 10 along x and y and the strength of 5, and this way you notice that this noise will be applied to the reference object, not to the instance and to the master object. Now, something interesting happens when I apply the noise modifier on top of the bend modifier. Notice if I choose the bend modifier and I change the angle of the bend, you see that the polygons on the reference object also change. And this would be pretty bad if this is a part of an animation. Let's just make an animation that starts from a bend angle of 0 to a bend angle of -60 degrees. And let's see what happens. So if I move the bend angle to 0 and I click on Auto key, and then I go to the end of the animation, let's go to the middle of the animation, and let's make the angle of bend to become -60, and then let's go to the end of the animation and bring it back to 0. And let's run this animation and see what happens. As you see, the object bends back and forth, and the surface polygons change, which is a pretty bad side effect, and we don't like this to happen. So how could we get rid of this problem? We could do this by essentially moving the bend modifier on top of the noise modifier. That is, we want to apply the noise modifier before the bend modifier. How could we do this? Now, we could go to the reference object and basically bring the bend on top and the noise at the bottom, and here the animation works properly. It first deforms the object and then bends the object. But the problem is that now that I put the noise modifier below the bend modifier under the solid line, these two modifiers are shared between the reference object and all the instances and the master object. So this also affects those objects too. So one quick remedy to this is essentially to move the both the noise modifier and the bend modifier above the solid line and just apply them to the reference object. And so as you notice here, the object, if I run the animation, the object deforms, twists first, then the noise applies, and then the bend applies on top of it. And so in this case, you would see that the object's polygons would not change because noise first applies before any other parameters change. And the problem with this is that now the bend modifier and the noise modifier are not shared between the object and its instances and the references. And the instances and references are now not bent. Actually, the instance and the object are not bent. So this is a quick remedy for this. Now, if I wanted to also apply the bend modifier on the reference and the instance and the master object, I could do that essentially by applying instance modifiers, and we'll talk about the instance modifiers next. But first, I need to talk about the 3ds Max data flow, the things that I just talked about here on the 3ds Max itself. I would like to show you actually in a diagram, and then you can make more sense of how these deformations and modifications and transformations are applied on the pipeline. All right, now that you saw how the objects essentially can be modified and essentially cloned, it's again a good idea to go back and look at the 3ds Max data flow and see how you can actually make objects and then make copies of these objects and how the process actually works. If you look at and remember from the previous chapters when we were talking about the process of applying modifiers on your objects, we said that the modifier basically uses a modifier stack, and it's basically careless about when each modifier is created when you were creating the object and modifications on it, but it actually looks at where the modifiers are placed in the modifier stack. So if you remember from last week, if we applied a bend and then a taper on top of bend, or when we applied the taper first and bend next, the result of the object would look differently because the 3ds Max starts from the bottom and goes all the way to the top of the modifier stack and applies one modifier after the next. But the same process of applying one thing after the other is true for the entire process of creating a three-dimensional object. And this is how it actually works. The pipeline takes from the beginning the object parameters, like the kind of object that you want to create, a sphere, cylinder, and the other kinds of objects, and its parameters. For example, the length, the width and height and length of a box, or the radius of a sphere, and so on and so forth. So if it applies those parameters first on the object, then it looks to see if there is any modifier in the modifier stack, and then it applies the modifiers from the bottom of the modifier stack all the way to the top. And then it applies the transformations. And the transforms are the three transformations of scaling, translating or moving the object in the 3D environment, and rotating the object. And it applies these transformations pretty much in this order. First, it applies the scale, then it applies the movement or the translation transform, and finally it rotates the object. And finally, it applies the properties to the object, such as the textures or maps or materials and the lighting and the colors of the lights and stuff like that. So this is the pipeline of 3ds Max data flow. And what happens when you create a clone of the object, or basically you hold shift and move the object and create a copy of the object, and you assign it as a clone, a copy, then that means that this pipeline for the two objects are completely created separately. That means that your objects do not share each other's parameters, do not share each other's modifier stack, and of course they never share their transforms and the properties, regardless of if they're a clone or they're an instance or they're a reference. So basically the copied object, which is not an instance or reference, do not share anything. And that is why when I was changing the size and the length and height of the copied object, it wouldn't change anything on the master object. Same when I was changing the colors, or when I was moving the object around, and when I was applying modifiers in the modifier stack, it wouldn't share anything. But when you're talking about instanced objects, you see that the objects and instances share each other's parameters and each other's modifier stack, but they do not share the transforms and the properties. The reason it's actually a good thing for the objects not to share the properties and not to share the transforms, because if they don't share the properties, then you can make one object, and then you can make many instances of this object, and you can give different materials to their to the different instances, and that would be a good thing. Same with transforms, in that you could make an object, and then you could make instances of this object and move these instances around in the world, rotate them and scale them, and not change the location and the scale and the orientation of your original objects. Okay? But another thing that's important is that sometimes you want to make an object and you want to make modifications to this object, and then you want to make copies of this object, and you want to keep these modifications. The instance objects share the modifiers and the modifier stack of their parent object. That is, when you make an object and then you create an instance of that object, and then you make modifications on either the object or the parent, the modifications will apply to both. And that's how you can create same objects with the same looks and then copy them over and over and over again. And also they share object parameters. So if you shrink one of the objects, either an instance or the master object, the other one would also change, because the parameters and the modifier stack are shared in the objects and instances, but the transform and properties are not shared. The objects and references also share modifier stack of the parent object and the parent object's properties, but the reference objects can also have their own modifier stack, and that was the modifier that I showed you when I was putting the modifiers just for the reference, and that they would look just original font size, and the modifier stack that was shared would look in boldface. And that way you can actually make an object, make modifications to it, make a reference for it, and then make more modifications to the reference without worrying about making changes to your master object or the original object. Now, there is a special kind of modifier that's called the X-form or transform modifier that you could use to transform and share transformations between the master object and the original object. And finally, there is another kind of modifier that's called an instance modifier that you could apply on two different objects and share these modifications. Remember, from the object that I was creating, I wanted to apply noise and bend on the object that was referenced. And in order to keep the object lock, I had to take the bend out of the shared modifier stack, and that way my original object was not bent. And if I bend the original object, it would apply an extra bend on the reference object, and that wouldn't work. The way to deal with this kind of problems is through the instance modifiers. You can make two objects, or you can make an object and a reference for it, and then you can make modifications to one object, and then copy that modifier to the other one, and this would basically copy an instance of the modifier to the second object. Basically, you can paste an instance modifier, and I'll show you next how it works. And that way, you can share some instance modifiers between two different objects and make them change accordingly. So let's see how the instance modifiers actually work in 3ds Max. Okay, so let's see how the instance modifiers actually work here. So I have an object like this box, and what I want to do is that I want to make an object that I want this original object to be twisted and bent, and then I want the object that I want to basically be built on this original object, or the master object, to have a unique noise on it. So what I could do is that I could use instance modifiers that would apply to two objects, and then I could make a unique modifier just on one of the two objects. So the idea here is to create an object like this, and then make a copy of this object. So hold down the Shift key and then drag your left click mouse and then create an object and make this object box copy. Now remember, these two objects don't share anything in general. So if you change one of the two objects, the other one does not change, and if you apply modifiers to one, the other one will not be applied. So you could create a bend modifier on this object, on the master object. So let's make a bend modifier on the master object, and then let's drag the angle of this bend modifiers to about 45 degrees. And we wanted this object also to have a twist object. So what you could do is that you could apply and copy this bend modifier by right-clicking on it and copying on it, and then click on the second object, and then click on box, and then paste instance. This way, an instance of this modifier will be applied on the two objects, and as you see in both objects, the bend modifier would look differently, or actually it looks in bold, in italic or italicized shape. So this way, if you change one of the modifier's parameters in one object, the other one would change. Notice these are two different objects, and if I still go to the box object and change the height of this object, it would not change or affect the other object, okay? Because there are two different ones. One is just a copy clone. But the only thing they share is the bend modifier. Let's say that you wanted to apply a twist object on both of these objects. Let's click on the copy object, and then let's click on box, because I want to add a modifier on top of box, not on top of bend. So here I could add a twist parameter or a twist modifier, and then I could increase the angle of twist for this object. And so here's how it actually looks like. And notice if I change the twist, nothing happens on the other object. So what I could do is that now I could make a copy of this modifier I created and make it into an instance on the other object. So I can click on box and click on paste instance. So you see on top of the box there's an instance of twist object, that is twist modifier, that is applied. So if I move the parameters or change the parameters of one, the other one does not get affected. And finally, I can click on the bend modifier on the object that I want noise to be applied on, and I can apply a unique noise modifier on top of it. So click on noise, and now you can change the parameters of the noise here, or actually make it smaller. Let's make it 10, and the noise will be applied on just the original object, not or one of the objects, and not on the other one. So the two are sharing essentially these parameters this way. Basically they share instance parameters. Now I can make an animation here of these two objects, and that would be essentially really useful, and because now the noise is applied on top of the bend modifier. Or actually I could drag the noise modifier down before the bend, and this way I won't have the problem that I was discussing earlier. If noise was on top of the bend and you were animating the bend parameters, the noise would affect the polygons on the surface. So let's see how it works. If the noise is on top of the bend modifier here, which is an instance modifier, and I animate the bend parameters, so let's click on the auto key, and let's make the bend parameter 0 at frame 0, and let's make the bend parameter angle 50 at frame 50, which is the middle, and let's go back to 0, which is the last frame. And if I animate this animation, you see the look of the polygons on the surface of this object change. Now, all I need to do is to make the noise modifier apply before bend modifier, and that way the animation would go much more smoothly, as you can see here. And so I can now change the amount of bend modifier in the instance modifier here, and so essentially it would change the amount of bend on the two objects. So at this auto key, at time 0 it's 0, 180, and back to 0, and run the animation. So this way I have two modifiers that are instanced, the twist and bend, and I have the noise modifier that is unique to just one object, and this is the animation that looks pretty smoothly. Okay, now that we talked about the data flow in object creation and modification in 3ds Max, we saw that transforms are applied right after the object parameters or creation parameters, such as width, height, number of segments, and stuff like that are applied. And they are not shared within objects that share the modifier stack. So this creates a little bit of difficulty, especially when you are dealing with lots of instanced objects and you want to modify and animate them. In that, let's say that you have a scenario that you have a set of, let's say, objects that look completely alike, and then you have a lot of them, and then you want to move them around in a scene and animate them, like a row of soldiers, essentially, marching. Because movement, also scale and rotation is a transform. The objects, although instanced and share geometry, they don't share their transforms. And if you want to make an animation, you would have to move everybody at the same time. And so this creates a bit of a problem. And also, when you're dealing with non-uniform scale, that would also pose a little bit of difficulty, especially when you talk about animation, keyframe animation. You'll see how that essentially works and poses what kinds of difficulties. And to address these issues, a special type of modifier is created that is called the X-form modifier, or which stands for transform modifier. And this kinds of modifier has a gizmo, and the transformation is applied at sub-object level on its gizmo. And when it is applied, it essentially, as a modifier, but instead of changing the geometry of your object, like bend and taper modifiers, it would change the location of your object, orientation of your object, and the scale of the object. So what you could do is that you could apply this modifier in the modifier stack, and this way, by changing the order of modifications that you want to do, for example, if you have a scale modifier on top of a rotation modifier, which is an X-form modifier, then your object first gets rotated and then gets scaled, which you cannot get from the transform or transformations of the object in the pipeline. And also, if you have instance objects, you could apply this X-form modifiers, essentially transform modifiers, on the modifier stack of either the master object or any of its instances, and it would automatically apply to all of the instances of the same master object. And this way you could create that animation of marching, a row of marching soldiers, essentially, through the X-form modification. And I'll show you in a little bit how it actually works. So notice that this also transformation applies on the gizmo of the transform modifier rather than the gizmo of your object. So if you get out of the sub-object level, you see that the pivot point of your object still stays the same. The other idea that I want to talk about is collapsing the modifier stack. When you put modifiers on top of modifiers on top of modifiers in a stack, especially when you have lots of complex objects, all of these modifications have to stay in the CPU memory, and the CPU would have to perform these modifications on your objects. Or essentially, it has to maintain a relevant information from these modifications or the modifiers in the stack. That poses a lot of challenges on the CPU and the memory requirement of your objects. So if you keep all these modifications on your objects, you have a reason to do so, because at this point, all your objects and the modifications are in the form of parametric equations and in a parametric form in the memory of the computer, and you can change the parameters even all the way down to the creation parameters of your objects, such as the number of segments or width and height of your objects automatically, and it would propagate through the modifier stack, and it would work with the look of the finalized object. However, you could right-click on the object, and from the quad menu, choose Convert to Mesh or Convert to Editable Poly to collapse the modifier stack. In this way, when you collapse your modifier stack by converting your object to editable mesh or editable poly, what happens is that all of the modifiers that are applied to create the final look of the object will be calculated and then will be burned on the surface of the final object, creating vertices, meshes, surfaces, and polygons on your object, and give you a finalized product of the object. And what you could do at that point is that you could edit this object by manipulating its vertices, its edges, and its surfaces, and its polygons, essentially, to create more complex objects. The advantage of this collapsing modifier stack is that you burn your modifications on your object, you get the ability to modify and manipulate your object physically, but what you will lose is the fact that then you cannot perform any changes to the creation parameters, or essentially to the parametric form of your object, such as the height of the object essentially as a whole, or the length of or the number of segments and stuff like that. But on the other hand, you gain the ability to manipulate your objects in a sub-object level, as I said, working with the matrices, vertices, moving the vertices around, welding vertices and stuff like that, and working with edges and things like that. Later on today, we'll see how we can actually use this editable poly and editable meshes, which are two different kinds of objects, to create more complex objects. For this reason, it is crucially important to know when you're pretty much done with the final look of your parametric object, and you want to basically collapse the modifier and make the final object. And another idea to also know about is that you don't have to collapse the entire modifier stack. You could right-click on one of the modifiers in the stack and basically collapse. When you right-click the modifier, the pop-up menu opens, and then you can click on Collapse To and collapse your modifiers stack up to that modifier, from the bottom of the stack all the way up to and including the modifier you right-clicked on. And all of the modifiers that are above will still stay the same, and so you could still use those modifiers to change the look of your object. So let's go to the 3ds Max, and let's see, first start with the X4 modifier, and then I'll talk about collapsing the modifier and how you can create new objects. So here's the 3ds Max, and I have this object essentially here, and so it has I already have the X forms. Okay, let me remove all of these X form modifiers. So I have the object essentially. So here's the object, and I'll make an instance of this object. And this would be an instance, and I call this box instance. Let's make another instance. Okay, so I have a box object, box master, box instance, and box instance 1. And as you see, bend and twist are already applied to this. Now, if I move one of these objects, essentially, you see that nothing happens to the other object. So this way, if I wanted to make an animation and I wanted these objects to essentially move along this way, and along the way that they're moving, I want them to kind of rotate, then I would have to, for each keyframe, I would have to move all of them, align them, and rotate them, and perform this operation over and over again. So I don't want to do that, so I will go and I will use a xform or transform operation, and I move the gizmo and rotate the gizmo of that xform operation in my keyframe animation. So let's click on the auto key, and so at the first frame, actually let's first add the transforms. So let's go on the transform, which is the xform operation, and let's add 2 xform transforms here. So the first xform transform, on its gizmo, I apply a rotation, and then on the second transform on its gizmo, I apply the translation to move all the objects. So let's go to the frame number 100 in the keyframe, in the auto key animation, and at the frame 100, let's assume that I want to transform all these objects all the way down here. And notice when I do this movement, all of the objects essentially transform, and they're and when I go at the when I go out of the sub-object level, you see the gizmo of my or the pivot point of the objects stayed the same. So let's move back everybody at the beginning, and for the first transform, I want everybody to rotate along the x direction. So I rotate. I click on the select and rotate, and I rotate all these objects essentially 90 degrees on their gizmos. So that is the first xform transform that I applied in this animation. Now, in the next transform, I want to move all these objects along the way to the 100 frame, or to the end of this frame. And so if I go out of my sub-object, my keyframe animation, and I run the animation, as you see, all these objects essentially transform. And one reason that I needed to put the rotation and the translation differently is that when you do rotation after the translation, then and this is only applied on the gizmo of these objects, you are translating your objects, and the rotation would apply around the pivot point of the object on the gizmo of this these objects. So that would give you a different kind of animation. So for this particular animation, I needed to have my rotation transform before the translation transform, or the movement transform. Okay, so here's how you actually can use transformations essentially to apply one transform on multiple instances of one object. Okay, now when you're pretty sure with the final look of your objects, and let's go out of the sub-object level, and so as you see, the pivot point of the xform is essentially different, but for your objects, your pivot points are essentially they won't change and they stay the same. So at one point in time, you might be thinking of essentially wanting to collapse your modifiers. So what you could do is that you could right-click, select an object, right-click on it, and select Convert to Editable Poly or Editable Meshes. So if, let's say, click on the Editable Mesh, then my object will become an editable poly, and here's how it looks like. Then I could make manipulations to its sub-object levels. As you see here, I can work with its vertices, with its edges, polygons, borders, and elements. So for example, I could pick one vertex, for example, and translate this vertex a little bit to the left, or I could click on a polygon, and then I click on the surface, and then I could extrude this polygon or change the polygon shape. And we will see how we can work with editable poly and editable meshes a little bit later. Or you could choose one object, essentially, and from one object you could transform or collapse up to a particular level in your object. So at this point, if I right-click on the bend modifier and click collapse to, then it would ask me if I would like to collapse to, and then I would click on yes. And so now I have my editable mesh, which is this object, and I could again work with its different sub-object levels, and I still have my transforms essentially, or my other transformations that are applied on the upper levels of my my stack. Whereas this object still essentially, actually they were instanced. So when I changed one into an editable object, then the other one also gets applied. Okay. So another way to model objects is to use two-dimensional shapes for modeling three-dimensional objects. Shapes basically are types of geometry that use vertices to control their curvature, and they don't have any faces by default, therefore they cannot be rendered by default. You have to change their parameters in the rendering rollout on the command panel to make them renderable. You can use the create panel, and then you can click on shapes to make two-dimensional shapes essentially, or two-dimensional curves. And these two-dimensional curves are on their splines pull down list from the shapes icon. You can use two-dimensional primitives such as lines, circles, arcs, polygons, and things like that to create two-dimensional shapes, and then you can use these two-dimensional shapes to make three-dimensional solid objects. You can use either the edge method or the center method to create two-dimensional shapes. If you use edges, you can draw the boundaries of your objects, two-dimensional objects, or if you use center, you can click and then use left mouse drag to define the radius of these objects. So let's go ahead and make a couple of two-dimensional shapes, and then we'll come back and we'll talk more about renderable shapes and how we can make these kinds of shapes. So here we are in the perspective viewport. Let's go to the top viewport, and let's maximize the top viewport, and then let's make some shapes. If you go to the create panel, so far we were on the geometry panel. Now you can click on the shapes panel, and then you have the splines objects. You can also use extended splines or NURBS curves. You want to use splines, and now you can create different kinds of shapes. Now let's go and create a circle, and I have again the edge option that would define the boundary of this circle, or I could use the ellipse and go on the center, and then this would define, my left click defines the center, and my mouse drag defines the radius. You can use the n-gon, that's a polygon that you could create, and then you could use even text, or you could use a star and make stars. And so this would be the star that I create. I can change the points of the star, essentially 4, 3, 5, 6, 7, 8, and so forth, and create several different kinds of shapes. Or you could click on, again, creation, and then create a rectangle, and I'm in the edge property, or the edge creation method. And so here's essentially how your shapes work. Now if you go to the perspective viewport, you will see that your shapes don't have any faces, and they only are drawn with the with their wireframes. Okay, remember that I talked about two-dimensional shapes and that they cannot be rendered in the viewport by default. What you could do is that you could click on a shape, a two-dimensional shape, and then go on the rendering rollout and make it renderable in the viewport. When you do that, the two-dimensional shape automatically turns into a three-dimensional simple basic shape, and then you can change its parameters, basically either being radial or rectangular, and giving it some sort of a thickness, a number of sides, number of segments, and things of that nature to make it three-dimensional look. So this way you could create very simple three-dimensional primitives out of two-dimensional primitives that you don't have them automatically, like a simple picture frame. And also you could use the extrude modifier that I'll show you in a little bit to extrude the face, basically make a face with the two-dimensional shape and then extrude it along the z-axis or the third dimension to make a three-dimensional shape. This way you can create basic solid three-dimensional objects. You can also work with fillet parameters, which is essentially gives you a way to control roundness of sharp corners of the two-dimensional objects. And I'll show you in a little bit how they work. So let's go to 3ds Max and see how they actually work. So here I have these objects that I created, basically the three-dimensional objects. First, let's go to this star shape, and let me show you how the fillet parameters work. So I want you to particularly notice the inner and the outer corners here. If I click on this object and then I increase its fillet radius 1, let's say from 1 to 50, actually that was a lot, to 10, you see from 0 to 10 the roundness of this edge changed. So now its fillet is 10, 0, 10, 0. The outer fillet is the fillet radius 2, so if I change this to 10, you see the outer object is, outer corners are pretty much rounded. Now how I can use these two-dimensional shape to make a three-dimensional object out of it? It's very simple. One way is to use the extrude modifier. Now if you click on the modifier list and type extrude, the extrude modifier gets applied. And what happens when you apply the extrude modifier, a modifier will apply to this two-dimensional object, give it a face with 0 amount of extrusion. If you give it like a 10 degree or 10 value for extrusion, or 50 even, it would increase the height of this three-dimensional solid object by extruding the face 50 units along the z-axis. If you wanted to apply more modifiers such as a bend or other kinds of modifiers to this extrude modifier or to this three-dimensional object, you could change the number of segments in this object, and this way you can actually make this object. So you have the control of the output you want to have. Here I want a mesh, so I click mesh. If you click on NURBS, it would give you a NURBS object that is like this, or if you click a patch, it would give you a patch object. So I want a mesh object that is a very simple object. Now I can apply a bend modifier on top of this object, and so this way I can bend the object, or I can apply any other kinds of modifiers that I wanted to apply on my object. Okay, and I could remove the bend modifier. Oops, I could remove the bend modifier by removing or deleting the modifier. Another way that I said you could create objects that are three-dimensional is to make them renderable. So on the rendering tab or rendering rollout on the right-hand side here, if you click, you can see that you can enable the renderer for this object and then click enable in viewport. And when you click enable on viewport, you see that your object, instead of a two-dimensional object, it automatically applies a simple rendering mechanism to make this object renderable. So you could click on the object, and then you could change either radial or rectangular way of simple rendering. You could change the thickness of this object, and then you could change the sides of the object. By increasing the sides, you increase the resolution of the object, and you could change the angle of your rendering. And so this way you'll get this object. Now let's scale this object down so that you could have it in the viewport. So here's how your object essentially looks like when you make it renderable in 3D. Okay, same thing with your polygon. You can click on render and then enable rendering, enable in viewport, and then increase the thickness of this object to 20, for example, depending the size, and you can increase the sides. You can make it rectangular, and so simple rendering mechanisms. You can click auto smooth or enable or disable your auto smooth to create various kinds of three-dimensional looks. All right, so so the two-dimensional objects that we saw so far, or the two-dimensional shapes, are essentially curved surfaces or curved objects, two-dimensional curves, that are controlled with things that are called controlled vertices. And you can put multiple splines, essentially, and put them on the same object and create multi-spline shapes. And these multi-spline shapes are essentially, like, for example, the section cut of a donut is a multi-spline shape that is made of two concentric circles or concentric ellipses. And as long as you have multiple spline and you follow two basic rules, you can create two-dimensional multi-spline shapes that then you could extrude them and create three-dimensional complex objects. The two rules that you need to be careful about is that all of the spline must be contained within the same shapes. And later on we create a bubble blower object that is made of multiple splines, and then we extrude it to make a three-dimensional shape. Or we can create complex looking picture frames and things of that nature. So all those shapes must be, or splines must be contained within the same shapes. That's the first rule. And the second rule is that the splines should not overlap or touch each other. Otherwise, when you extrude, you can get unexpected results. As long as you keep those in mind, you can put multiple spline shapes and nest them within each other and then extrude a three-dimensional mesh object. That could be hollow, could have holes in it and stuff like that. The splines that you created, as I said earlier, are made, and the curvature of these shapes and splines are controlled by points that are called control points. And all of the standard shapes basically have CVs that are simply called vertices. However, these vertices are different from the vertices in a mesh object. In a shape, the segments between vertices can be curved, but in mesh they cannot be curved, and essentially they're just straight lines of a polygon. And the edges between vertices are not always straight lines. In order to get to these control vertices, you need to change your object or two-dimensional shape and make it editable. And you can right-click on the two-dimensional shape and choose editable, convert to editable splines. And when you convert your object to the editable splines, it would place the control vertices in the critical locations on the curve, and then you would be able to manipulate these control vertices and change them and move them. And essentially you can control the shape in a sub-object level. You can change and manipulate vertices, you can change and manipulate segments, which are the curves between two vertices, and you can change or manipulate the entire spline itself. There are 4 different types of vertices that you could work with. Corner vertices are those vertices that make straight lines or the two segments that come into the corner vertex are essentially made up of straight segments. The smooth vertices are vertices that enable a smooth curve to pass through the vertex, or essentially segments that passes through the vertex will be a smooth surface. Bezier control vertices or Bezier vertices are those vertices that make curved segments that have two handles for the incoming curve segment and the outgoing curve segment, that you can manipulate the tangent to or the curvature of the incoming and outgoing segments with those handles. And the Bezier corners are those that make segments with handles for the direction of the incoming and outgoing segments separately. And I'll show you how these segments and splines work. When you are working with sub-object splines, you can manipulate vertices. I'll show you how you can do that. Change the vertex types, delete them, add vertices, and I'll show you how you can work with segment or segments of your objects. You can split the segment, you can remove the segment, and things of that nature. And finally, I'll show you how you can mirror or work with the spline sub-object, mirror the spline, and essentially make a complete identical mirrored version of your spline, how you can make outlines for your splines, and so forth. So for this, let's go to the 3ds Max, and I'll show you how this works. So here I have the objects that I created. Let's look at this circle here. This circle is now a two-dimensional shape, as you can see. And it's basically just a circle that has a thickness of 1 and so forth. Now what I can do is a radius of 55, let's say, radius of 50. What I can do is I can access its control vertices by right-clicking on it and converting it into editable splines. So when you click on Convert into Editable Splines, your object turns into an editable splines. It's basically like collapsing your object and burning the vertices on top of this object. And if you click on the editable splines, little plus sign next to the object name, you will get vertex, segment, and spline sub-objects. You can also access each of those sub-objects from the selection rollout. So if you click on the vertex sub-object, you see that you have essentially now access to the vertices, and you can now click on vertices and work with them. The type of things that you can do with the vertices are essentially you can create line, you can attach and stuff like that. But what is really neat about working with vertices in the spline is that you can change the types of vertices that you have. And let's right-click on this vertex, and you see the Bezier corner, smooth, and essentially you can reset the tangent. So this is now a Bezier spline. If I click on the Bezier corner, I have a Bezier corner spline object here. And you can click on the little rectangular or little box here, and you can make changes to the direction of segments that come to this object. Yeah, we can do the same thing by moving, as you see, the Bezier vertex, and that would change the curvature of your vertices. This is a smooth vertex, essentially, Bezier vertex. Let's make it into smooth vertex. And the smooth vertex doesn't have any incoming and outgoing curvature, and the curvature on the two sides are controlled by an equation that defines the smoothness. And you can right-click on this and make this into a corner spline. And a corner spline, again, does not have an incoming and outgoing curvature, but you can move this corner spline and manipulate the angle of the incoming and outgoing, the angles of this corner, essentially. Okay, so this way you can create complex objects. Now, in terms of the segment things that you could do, you could move the segments again. Along any direction you want, or you could apply other kinds of tools to them. You could delete the segments, as you see here, and then when you go to the spline sub-object, you could click on the spline and pick the entire spline, move it around, and you could use things like mirror. So click on the copy checkbox, and then you can mirror horizontally, mirror vertically, and mirror both. So if you click mirror horizontally, it would give you a mirrored version of your spline. If you click on mirror vertically, and you click on mirror, it would vertically mirror the spline, as you see here. And finally, you could mirror both, and that way you create this complex or a spline that is mirrored on both directions. So you can work with all these different kinds of sub-object tools that you have to work with these splines. For example, let's go to the segment spline and click on a segment, and then you can click on insert, and then insert vertices in your spline. And you could go back to the vertex sub-object and change these vertices to, for example, Bezier vertices. Bezier vertices, that would be a Bezier corner vertex, and you can make this into a smooth surface. And this way you will be able to handle your vertices appropriately. So this was a Bezier vertex, and I can change the curvature of this vertex or the segments. Now if I click on the spline again, and I click on the spline itself and go to the outline, you could create an outline for your object, essentially. So this would give you another object. And of course, I had already clicked on the copy, so it keeps a copy of my object. And then you could go back to the segment, to the vertex sub-object, and then try to move these vertices in such a way that they won't have, or basically your spline would not overlap to make it possible for you to be able to extrude. And when you're done, you can go back to your perspective viewport, as you see here, and then click on your object, and then click on modifiers, and then extrude the object at 50 degrees, and this will give you a three-dimensional object. Okay, that said, let's go and create a Valentine's heart, and I'll show you how this actually how we can work with all this stuff that I talked about. So to do this, we'll go to the top viewport, and we'd like to create a heart shape and maximize the top viewport. And what we will have here is that we have the two-dimensional shapes, that's essentially splines that we have here, and we could use a circle. And I'm on the center option. I'll click on the snap tools, essentially to make it snap to the grid, and then I'll increase the radius of this shape. Okay, so this is my circle. And what I need to do is I need to right-click on this circle and convert it into editable splines. Now my circle is converted into an editable spline, and I would want to change this shape into a heart shape. To do that, I'll need to remove half of this this shape. So go to the segment and then click on this left segments. When they're turned red, just remove them. Next, I need to move these the splines, essentially, to be able to make a half heart shape. I need to move the vertices. So what I will do is that I click on the vertex sub object, and I move the top vertex a little bit down, and then I right click on it and make sure that this is a Bezier vertex, and then I change the direction of this vertex, and I'll move this left vertex or this right vertex up a little bit, and so this kind of looks like the half of the shape of the heart that I want. But it's not quite there yet, and what I can do is that I can insert a vertex right here in the middle, and so actually I added 2 vertices. Now I need to move these vertices by untoggling the insert, and then right click on the vertex and make it into a Bezier vertex. And now I'll try to change the shape of this Bezier vertex. So that it would give me a kind of neat heart shape that I'm looking for. So this goes like this. So now I have half of the heart shape that I wanted to create. Now next I need to make a copy of this and essentially mirror it. So I need to click on the copy checkbox and then click on mirror horizontally, and then click on the mirror. So this makes a complete mirror of this object. And then I'll click on the 2 objects as you see here, and because my automatic welding threshold is 6 units, when I move them next to each other, these vertices, the 2 vertices that overlap, get essentially welded together. So now I have 1 vertex here, and 4 vertices that are mirrored of each other horizontally. Now I get out of the sub spline or sub object, and now I have my object created. And if you look at the perspective viewport, you see that this object is now made. So get out of the snap toggle, essentially toggle the snaps out so it could move freely. And the final process is to apply on this object an extrude modifier and extrude it at, let's say, 20 with only 1 segment. And this way you can create a 3-dimensional object from a 2-dimensional spline that you created, and you just extrude the face of the object. Okay, I talked about the 2-dimensional shapes that you could create, and we worked with this circle essentially to create a 2-dimensional object, and then I made that 2-dimensional object, which was a circle, into a heart shape. You could also do the same processes with essentially lines and the line tool. Actually, when you create a line, you automatically create an editable spline object from scratch without having to collapse a stack. And this way you could essentially go directly to the modify panel and modify your object. And I'll show you several kinds of modifications that you could do on lines and the editable splines that you can create. So to create a line, you click on line object, and then you simply click and you can make straight lines. Now when you do this, you create just straight lines. How about if you wanted to make curved lines? One way to do this is to go to the modify panel after you created your object, and then go to the vertex option and change all these vertices, which are right now all of them are corners. You can change them into Bezier and Bezier corners and create vertices, right? Now another way is to essentially create them from scratch when you're creating a line. To do that, when you click on your first vertex and you want to add the second vertex, left click. While holding the left click, you can drag your mouse, and this way the vertex that you just created becomes a Bezier vertex. And so when I left click and drag the mouse, I automatically create Bezier vertices and Bezier vertices and Bezier vertices. I'm left clicking and dragging. And next, you could essentially go to the, if you wanted to close the vertex, you could go to the first vertex and click close to it. The spline object asks you if you want to close the spline. You can click on yes. Now, to have that enabled, you need to go to the modify panel before you make the shape. You click on the endpoint auto welding, and then automatic welding. You check that box, and then you make a threshold for the automatic welding. Now you have created a new spline, and so that is a closed loop. You can click on this spline that you created, and now you automatically have the editable line that you can access its sub-objects. If you're on the vertex sub-object, you have several options that you can make. When you add new vertices, you can choose what kind of new vertex type you want to add. Let's add smooth vertex types. And then you can go down and click on Insert, and then go on the object and left click once, and this way you can make this vertex essentially or insert new vertices. You can click somewhere else and then left click, drag your mouse, and when you're happy with it, leave the left click and right click, and left click one more time, and then left click. When you're happy with the shape, left click one more time, and then right click. So this way you can add new vertices to your object. You can click on Refine and add refined vertices essentially to make refinements to your object. And you can have several kinds of tools. You can click on Delete and go ahead and delete vertices that you don't want them. Just select the vertex and then delete them. Okay, you can perform properties onto the segments. You can click on Divide and change the segment into 2 segments and so forth. And you could also do the modifications to the spline object itself. You can click on vertex sub-object and click on the vertex and use the chamfer or fillet essentially that would change your vertices into essentially segments. So this is a fillet, and if you click on this vertex, you can increase the chamfer properties of the newly created segment. So go ahead and play with these properties. One of the last things that I wanted to tell you about is how you could actually add multiple spline to the same object that I just talked to you about, that you could create multiple objects with. To do that, you could click, you could create a new line. Let's say that I create a new line or a new object like this, and now I want to essentially add these two objects together and create a multi-spline object. So click on one of the objects, and then if you are on either on the entire object or in the spline object, sub-object, and then you click on Attach, then it would allow you to choose another object, and then you can click on it, and this way you will attach the two objects, and now these two objects are the same objects, and now you have segments, vertices, and spline sub-objects properties for these objects. And you could extrude now this entire object, and I'll show you how you can do this. So go to the object itself. The object is selected, and then go to the perspective viewport that you see here, and then apply an extrude modifier. And this way you can extrude your object. Simple enough. Another modifier that I wanted to talk to you about is lathe modifier that would allow you essentially to make round objects from a shape. You create a shape in the let's say the front viewport of your 3ds Max and align it with the axis, and then you apply the lathe modifier and it spins the shape around the axis to form a three-dimensional object. Sometimes this is called a revolve or a surface of revolution because the shape revolves around an axis to create the surface. The lathe modifier is available only for two-dimensional shapes, and it's not available for three-dimensional shapes. As you saw here, I applied the extrude modifier, but lathe modifier actually makes a symmetric round shape. To make the lathed object, you need to maximize the front viewport and turn 3D snap, and then create the two-dimensional shape or half of the shape, like the half Valentine that we created, and then apply lathe modifier on it. And this way you can basically make the lathed object. There's one particular thing that might happen is when you apply the lathe modifier, the object may look inside out. That is, that you see darkness on the outside of the object. What you need to do is to use flip normals, or to check the flip normals checkbox on the panel, and this way, when the object looks inside out, that's when the back side of the faces of the object or the polygons are facing toward you. When you flip normals, the polygons will flip over and you see the outward facing of your objects. In most cases, you want the points at the center of the lathe to be welded to prevent rendering errors. Sometimes flickering might appear on top of or the bottom of the lathed object. You need to turn on the weld core option to fix this process. Another common problem with lathes is that the axis is not properly aligned, and the lathe modifier cannot do this. So it has a single sub-object type, the axis. The sub-object axis mode lets you move the lathe axis, and in this way you can edit the resulting three-dimensional object and correct the errors that would basically occur on the faces of the object. So next, let's create a lathe bottle that essentially we manipulate and we work with to create from a two-dimensional object. So remove everything, and this way we need to go to the front viewport and maximize the front viewport. Next, I need to turn on the 3D snap and basically make it on the grid points, and then I will create lines that would basically make my two-dimensional bottle, and then I manipulate these lines to make them round, and finally I'll apply the lathe modifier. Okay, now next I want to create a lathe object, and I'll show you how the lathe object works. What you need to do essentially is to apply lathe modifier on a two-dimensional shape. There are a couple of things you need to make sure that you are aware as to it actually works. First, you need the object to be completely aligned with the axis of revolution, and that you want the lathe modifier create the three-dimensional objects around the axis. For that, make the snap grids activated, and then draw the outline of the object, then make modifications to the outline of the object, essentially refine the curves, change the type of vertices or control vertices to smooth, to Bezier corner or Bezier vertices, and create the shape that you actually would like your object to have. Now, once you have the object essentially completely the outline, half of the outline drawn, and essentially aligned with the axis of lathe, then apply the lathe operation, and then click on the axis of lathe sub-object, and move the axis to get aligned with the axis you made the alignment of the outline, and then you can modify your three-dimensional object. There are a couple of things you might need to do. If necessary, your object looks dark, flip the normals. That happens most of the time. And you can then also go back to your two-dimensional spline and make modifications to the interpolation rollout. Interpolation rollout essentially tells you how many segments the three-dimensional object will have along the lathe outline. You could either make it adaptive, or you could assign or give it some particular number of segments to the line segment. Now, let me just go ahead and create a bottle here for you real quick to show you how lathe operation actually works. And this will be one of the many assignments that we'll do a little later as a part of this week's objectives. So for the lathe operation, you need to be in the front viewport. So go to the front viewport and toggle on the snap. And you can right-click on the snap, go to the grid and snap setting, make it grid points, and then accept it. And then you need to go and create your two-dimensional object. So click on the line and left-click, and one more left-click, and then one more left-click right there, and then go ahead and left-click right there. Actually, I need to okay, I lost my click, so let's click Start New Shape, unbox it, uncheck it, and this way I can add to my current shape, and then I just simply left-click and then left-click one more time. So I keep left-clicking, and you see I uncheck the Start New Shape. This way it will not start a new line for me when I lose my line object. And then click on the 3D snap, and here we are. Now, unfortunately, I have now two objects. So what I can do is that I can go ahead and attach these two objects, go to the modify, and then click on the spline of the editable object, click on geometry, click on attach, and click it to this other spline. Now the two spline are the same objects. So now I have the outline of my object created. Next, I need to make sure that I refine this object. So go and click on the segment, and then click on refine, and then I'll add an extra vertex there, and I believe that should do it. Then right-click somewhere, and then click on the vertices, and I'll make this vertex a smooth vertex, and this one also a smooth vertex, and I'll make this one also a smooth vertex. Actually, I need to make this one a Bezier vertex. Okay, this is a Bezier vertex now, and I'm making changes to make sure that change this vertex into smooth as well. And so this is kind of sort of the look that I'm looking for, essentially. Let's make this a little bit more appropriate. So this is kind of like the look of the object that I needed. So just to make it a little bit more interesting. Okay. Okay, so this is the outline of the bottle. And next, click on the object itself. As you see, this is how the object looks like. And in the in the perspective viewport, it looks something like this. Now, go back to the front viewport. Actually, I did that in the top viewport, which wasn't the right thing to do. But I could rotate it into the front viewport. Let's rotate this into the front viewport and have it stand up, essentially. So that's how it looks like in the front viewport. Let me move it a little bit up so that it's aligned with the axis. Okay. Now click on the object and go to the modifier and apply the lathe modifier. And here's the lathe modifier applied on the object. And the object doesn't look quite right. So what I need to do is I need to go to the perspective viewport with Alt and center button. I could look at the object and then click on the axis of the lathe and then drag the x-axis on the front viewport to the left to create the object. And once your object is made, if the flip normals had to be done, you could see how it looks like. Okay, now this is how my object looks like, and if you go to the bottom, you could actually drag the x-axis until you actually get the look of the object. If the weld core is not selected, your object might get a little bit of reflection at the bottom of it. But if it's actually selected, the core segment will be, the core vertices will be welded together, and your object will look pretty reasonable. Now if you press F4, you'll see that this, in a perspective viewport, your object looks something like this. Now if you go on the editable spline and you click on the interpolation rollout and you change the number of splines, let's say to the 32 number of steps, and then you click on the lathe object, your lathe object will have a lot more steps essentially, and that would make it look smoother. Or you could go to the editable spline and click on the adaptive checkbox, and then it automatically adapts the required number of splines to create a reasonable object. The difference between adaptive and the automatic and the manual selection is that if you make it adaptive, the interpolation mechanism would change the distance of the segments essentially. For the high curvature parts, it creates more segments. For the low curvature parts, it creates less segments. Now, if I uncheck the adaptive, it would automatically place the 32 segments in an equal distance. And so if you look at the look of this object with 32 segments or with an adaptive segment, you see that the adaptive looks a lot smoother and it has a lot less number of segments. These are like 20 segments. If I go and make the step essentially non-adaptive and make it like 12, then the lathe object looks something like this, which is not really nearly as smooth as I want it to. And it has almost the same number of polygons. Okay, so this is the lathe operation. Okay, so far we have worked with the two modifiers that would let us make three-dimensional shapes from two-dimensional shapes, and we saw extrude modifier that would make a flat three-dimensional shape by extruding a two-dimensional object along a straight line that is perpendicular to its plane. And we saw the lathe modifier that would make a three-dimensional shape by taking a two-dimensional shape as profile and revolving it or rotating it around an axis, and that would make the three-dimensional shape. There are other kinds of modifiers that would let us create three-dimensional shapes, and I'll show you how these modifiers work in 3ds Max. There's the bevel modifier that it would basically extrude the two-dimensional shape along a straight line which is perpendicular to its surface or to its plane, but while it's extruding, it also creates an outline. There are up to 3 extrusions of the shape that can be created by one single bevel modifier, and in the bevel value rollout, you can change the height of level 1, which is the first extrusion, and if you make a negative value, essentially, it's better because the shape extrudes back into the viewport if you are in the default viewing position. The angle of bevel is controlled by the extrusion distance, which is the height, and the outline parameter. The outline works similarly to the outline tool in the editable splines, which basically creates an outline automatically from the shape. So I'll show you how these values work and how they change the shape of the object. Some of the shapes, when you bevel them, they result in three-dimensional objects that have sharp spikes in them. And the reason for that is when you use objects that have sharp edges and corners, when you bevel them by bevel modifier, it enlarges and shrinks the shape while it's extruding the shapes actually, and it makes sometimes some of the lines of the shapes kind of cross over themselves, and this would create those undesirable artifacts. And to make sure that it doesn't happen, you could use the option of keep lines from crossing that you could check, and this prevents those spikes. But eventually you would have to manually modify your shapes to get rid of them, or these artifacts. There's another modifier that's called the bevel profile modifier, and it works pretty much like the bevel modifier. The difference between the bevel and the bevel profile is that bevel essentially automatically extrudes along the object and along the straight line while creating the outlines, whereas the bevel profile takes another two-dimensional shapes as the outline, and then it uses that shape to extrude. So basically what it does is that it extrudes the second shape along the surface of your object, and I'll show you how that works. And finally, there is another modifier that's very useful, and it is a bevel. It is actually called a sweep. And what it does is, if you look at bevel and extrude modifier, they only extrude the two-dimensional shape along a straight line that could be perpendicular to their plane, or it could be at an angle. If you wanted to make the extrusion from a two-dimensional shape along a complex curve, you couldn't use the extrude and bevel profiles and bevel modifiers automatically. On the other hand, with the introduction of the sweep modifier, you could make a two-dimensional shape and use that two-dimensional shape as the extrusion path to create a three-dimensional object. To make a sweep object, you can start with a two-dimensional primitive or an editable spline, and this would act as your sweep path, and then you can create another object, another two-dimensional shape, and then extrude along these the first path that was your editable spline or your first two-dimensional primitive that you worked. And this is very useful for creating interesting three-dimensional shapes, such as picture frames and mirrors and things of that nature, door frames, because usually they are a rectangular shape, but they have distinctive profiles, and you can create these objects with the sweep modifier. However, there's another compound object that we will see towards the end of chapter 3 or the middle of chapter 3, and that is called the loft object, and that is essentially a kind of complex sweep modifier, but it's actually a primitive. So let's go to the 3ds Max and let's create some bevel texts and use bevel profile and sweep modifier to see how these things actually work. Okay, let's go to the create panel and click on the shapes, and let's click on text, and let's in the Max text section, let's type in the text, let's say and this would be your text, and then click somewhere and you would see your text actually placed. Click somewhere on the front viewport, and your text will be created. Let's move this text to the middle of the screen. Let's zoom out. So here's our text essentially, and now let's maximize the perspective viewport. And so as you see, this text is not essentially renderable. So to make this a three-dimensional text, you could go to the modifier tab and select your object, and from the modifier list choose the bevel modifier. And as you see, this bevel modifier is essentially created for the object, and the bevel value at the moment is essentially 0. Let's make the start outline, leave it as 0. And for the level 1 outline, set its height at -4. So for the level 1 outline, let's set the height at -4. And then check, and let's go close to see how it actually looks like. So if you go in and press F4, this is how your bevel essentially extruded your first outline. And then let's click on the page and go to the bevel profile, click on level 2, and set its height at -20. And this way you will extrude your text another 20 units along the negative y-axis. So this is your second bevel profile that you could create. Now if you look at the level 1 and level 2, each of them, they have an outline. And so the outline for level 1, we leave it at 0. It basically does not outline the beveled or the extruded face of this object. But we can play with the outline of level 2, and we can drag the outline along the negative values or drag it up along the positive values. In this way, you see the changes that are applied to the outline of the page. So let me rotate this so that you would see how this outline essentially affects the way your object looks like. So positive amounts of outline make the outline of the shape or the outer surface of the shape larger, and negative amounts of outlines essentially make the outer surface of the shape smaller. Now that can be seen from the top viewport a lot better. So if you look at the top viewport, and when I'm dragging down the outline, it makes the outer parts of this shape smaller than the inner parts, and when I'm dragging it up, it would essentially make them larger. So you can create different kinds of shapes here, and the way to think about it is that it basically acts as a sort of kind of a fillet of some sort. Okay. Now as you see, when I'm increasing the outline here on the letter M, you see the spikes happening, and that is because the lines have essentially crossed each other while I was creating the outline. And so in order to prevent that from happening, you could click on keep lines from crossing, and then when you're decreasing the bevel values, it essentially cuts it at the smallest outline possible before the lines actually keep interfering or intersecting with each other. Now let's leave the outline for level 2 at 1, and let us change the outline for level 1. And so as you see, when I'm increasing the outline for level 1, the middle edges start increasing, and the actual surface of the object, which is where the start of the extrusion was, is small, so your object looks more three-dimensional in that sense. Okay, let's make the outline of this level at, let's say, 3. And let's look at the object to see how it looks like. It doesn't seem that we have any lines that crossed over. And when I'm increasing this outline at 4, you see the letter 3 essentially gets pretty ugly because the outlines start crossing over and they get caught. So there would be a potential optimum value to create a reasonable looking outline by increasing the outline of level 1. So it looks like 3 units of outline is essentially a very good value. Something between 2 and 3 for this particular text. It depends on the font size, of course, and the font value and all different letters that you use. Essentially, some letters have more curvature, some have smaller curvatures, and so the amount of outline that you can make is different. Essentially, that's what it is. So this bevel that we created, it essentially uses straight edges, and as you see, all these edges that are created are straight. And what you could do is you could also use for the bevel option surfaces, click on curved edges, and this would let you make curved surfaces or curved sides. The only trick is that the number of segments for the curved sides have to be more than 1. If you leave the number of segments at 1, then it will not make curved surfaces. So if you increase this number at 2, as you see, the surfaces that are created for the beveled surfaces and the beveled part of the object, they become essentially curved. And so by increasing the number of segments, you increase the roundness of these curves, and here's how it actually looks like. And the decreasing of these curvatures essentially make it kind of sharp. So by increasing the surface, the number of segments, you make your letters round. Otherwise, the letters will have sharp edges on them along the location that you had beveled. Another thing that is interesting to work with is the adaptive interpolation. And what that is, if you look at this letter number, the number 3 here, the surfaces that are created and the segments essentially are placed at essentially equal distance. And so if I create 2 segments, for each of the bevel sections, it has 2 segments, and all the segments are spread evenly. Now if you go to the text option and go to the interpolation section and click on the adaptive, you will see that the spread or the density of the segments are higher along the areas with higher curvatures or more curvatures, and they will be less where you have less curvatures. So it would automatically adapt the placement of the segments essentially along your objects. Whereas if you don't choose the adaptive option, you could change the number of steps that these segments are placed to control the roundness of your letters. Now notice if you press key 7, by increasing the steps here, the number of steps here, you increase the numbers of polygons that you essentially create. So here with with 5 steps, I have 5,500 polygons in this object. And when I click on the adaptive, it essentially increases the roundness of the object with 9,000 or about 9,000 polygons. If you wanted to achieve that amount of polygons, you would probably have to have a larger number of steps, essentially, in the interpolation. So with about 10 steps, you'd get about the same amount of polygons, and your objects would not look nearly as round and three-dimensional. Okay, so now let's remove this bevel object here, or bevel modifier here, by clicking on the modifier from the modifier stack, and then clicking on the remove from modifier stack option. And then let's make a profile that we could assign to this text, and that could be any profile. So what I will do is I will go to the front viewport again, and then I'll go very close to this object and zoom in, and then I try to make a two-dimensional shape, and that would be a rectangle. And so I make this rectangle here, and then in the modify section, click on the rectangle, and let's increase its go to its parameters, and let's increase its curve radius to a value of, say, about 4. Should be good enough. And then click on the object, right click on it, and convert it into spline. Basically make it an editable spline. Click on the object, and click on the segment from the selection part, and then let's remove this segment here. And this will be my profile that I created for the bevel object. And then click on the actual object by going out of the object mode, click on the text, and then from the modifier list use the bevel profile. As you see, when you apply the bevel profile, it actually made a flat surface for the object. You need to pick the profile, so click on the pick profile, and then choose the object that you made, and this would bevel your object essentially, or your text, by applying the profile. You can click on keep lines from crossing, and it would make sure that the lines that you created would not cross over. And the effect that I see here is basically made because the profile object that I created was a very big object. Now if I go and create a much smaller two-dimensional shape compared to the one that I have, I can make a better look. Okay, this is the object. Let's convert it to editable splines. Go to the sub object and remove this. Now instead of that big two-dimensional bevel profile, I can choose a smaller profile. So select the text, go to the bevel profile, and then click on pick profile and pick the profile. So this smaller profile that I created essentially made a much nicer effect. But as you see, the object looks a lot more flat essentially, and in this case we won't need the keep lines from crossing option. And so here's the bevel profile tool, just to show you how it actually works. Now let's work with the sweep property. So, as I said, in the sweep property, you could draw an object, a two-dimensional object, as a sweep path, which would be a complex curve, and then you could create a profile for your sweep and then apply the sweep property on it. There's just one thing that I want to mention. Before the sweep object that was introduced, or the sweep modifier, if you wanted to create this effect, you could use the bevel profile, but you could make a closed curve as the profile for the bevel, and that would essentially kind of simulate the effect of sweep modifier. But now we have the sweep modifier, and we can use this essentially. So for the sweep path, I'll create an ellipse here, and so this will be my ellipse, and let's move this ellipse to the center, and then I'll go close, zoom close in, and then I'll make a profile. Now, to make this sweep profile, I'll use the line option to create a nice looking profile. So this would be my first line, and then don't worry about the way it looks. We could always change the vertices, and I'll show you how to do this. So this is let's use this object actually, and then see how it actually works if we sweep this object. Let's make this object, select it, right click on it, convert it to editable splines, and then let's use this object as a sweep object. So click on the ellipse, which is my picture frame, and then from the modifier list find sweep modifier, and if you use the sweep modifier by using a built-in selection, you could use built-in sweep profile. So here's an angle profile that is used from the built-in, and let me show you how it actually works in the viewport. So in the perspective viewport, the angle sweep essentially looks something like this. Let me make this a smaller object. Okay, done, and let's add a sweep. And you could work with the sweep parameters essentially, and make the sweep profile essentially look differently. And so let's get closer. So here's how this angle works out. Let's go and change from the built-in modifier. If you put a bar, it just sweeps the bar around. If you put a half round, it essentially looks like a hemisphere. You could put quad round and other kinds of already made profiles, or you could pick the profile. So click on the use custom section and click on pick, and then click on the object or the profile you created. So here is how your object essentially looks like if you apply that custom profile. So it sweeps that profile around this object and creates your three-dimensional shape. Now, if you wanted to get a better look, you could zoom in and modify this line object that you created on the front viewport. So, and I'll show you how you can modify this shape by clicking on the line object and going to vertex mode and manipulating the vertices. So let's make this first vertex to a Bezier corner, and let's make this corner straight. Let's move this vertex a little bit to the right, and let's make it into a Bezier corner also, and let's go to a different viewport. Let's make this a smooth, and move it out. And then let's make this object another Bezier corner. Let's move it out. Let's make this section straight. And let's make this one also a smooth profile, and let's move these around to get a reasonable looking profile. Right. Let's make this one into a Bezier. Okay, this is kind of getting close to what I want it to look like, and let's just add another pixel here, another vertex here, and by clicking on refine, now let's see what this vertex looks like. It's a smooth vertex. Okay, so let's move this smooth vertex down here. Let's move this smooth vertex down here, and kind of like this. Okay, now that I have my profile, let's go out of the sub-object mode, click on the sweep parameter, click on the pick, and change the sweep profile. So if I go to the perspective viewport, you see that now the profile looks a little bit differently, and it actually looks a lot like a nice picture frame. Okay, so this will conclude our work for this week, and so please go ahead and just work with the learning module that is put up on the blackboard. And essentially, there's going to be a small assignment and also the further reading materials from the book that you might need to read if you haven't worked with the little tutorials that I showed you during this lecture. And we will continue working with more modeling tools and techniques. We started a modeling technique called lofting, and then I'll show you how you can work with polys and meshes that you could edit them, and what kind of editing processes that you can apply. With this, I let you go, and I will talk to you next week.